The next data type I want to cover is called a tuple. This is it's very kind of simple data type. It's very similar to a list, but there's two important differences. One is that tuples are immutable. Means they don't support item assignment. You can't change them in place, or you can't append to them. You can take a tuple and output it and add some stuff to it and change it as save it as a new tuple, but you can't change it and place it. You tend to use them for things where you don't want that it's like a list that can't be changed. So if you have a situation where you don't want things to be changed, you can use a tuple. Another thing is that they can be composed of mixed types of objects, whereas typically with lists we want to have a single kind of object. So I'll just give you some examples here. So we're going to create a tuple that's t equals 1, 2, 3, 4. And so the difference between a list and a tuple is that, or the way that you denote them is with a list you use square brackets, and with a tuple you use parentheses. And you might recall that when you combine things with a comma in your notebook, say you just type some expressions separated by commas, when it evaluates, it evaluates that as a tuple. So it's a tuple containing those things that you entered. So tuples support indexing, so you can pull out the first item here. You can get the length of it. You can create a new tuple with the same name. That is the concatenation of the previous one and the new one, but you cannot assign things. So if I uncomment this, it's going to give me an error, and it says tuple object does not support item assignment. So an example where you might want to use a tuple instead of a list is, so if you have a list of names, you can just use a list. But here we have a list that's got both strings and numbers. We generally want to avoid this, so we can use a tuple instead. So for example, we can have a tuple that contains someone's name and their age, and then those individual tuples can be combined as a list. I think for most purposes in this class, the distinction, you won't need to use tuples a lot, but well, as we come across different things, I'll point it out if we're using one or the other, and why that might be. The next data type is dictionaries, or in Python they're called dict, and this is a hash table that, well, in computer science language we call this a hash table, where you have a key that points to a value, and the way that you get from the key to the value is called a hash function. You don't need to worry so much about the math, but the advantage of using a hash table or a dict is that the items don't necessarily have to be stored in order, and the way that Python or the computer is able to look up the values is very fast. So in newer versions of Python, the items are actually stored in order, but they don't necessarily have to be, and there's some speed improvements to using a kind of lookup table like this. So the way that we indicate a dictionary is we use these curly braces, and then for each element we separate with a comma, and then the element is specified as a key colon value. Now here both the key and the value are strings, but they can be any kind of data type. Here we have a string and then an integer, and here we have a string as the key and the value is an integer. So we can store it that way, and then when we render it, we see it printed like this. So the way that we use a dictionary is it's similar to a list or a tuple, but with a list or a tuple, you're indexing based on the position, right? You're saying I want position 0 or position 5. With the dictionary, you're indexing based on the key, and the key will pull out the associated value. So you don't need to think about where the position is. You just need to know I want the dictionary value that corresponds to food. So it will give you that value, food, or this quantity. And a dictionary, like a list, is mutable, so we can change it. We can say I want to take the value corresponding to this key quantity, and I want to add 1 to it. So now we're going to do this d quantity plus equals 1. Whoops. And now if we look at d, now quantity has now been changed to 5. Okay, another way we can create a dictionary is specifically by naming the keys one by one and assigning values to them. So here we're going to reset or erase the value of d and just create an empty dictionary using just closed brackets. This works with tuples or lists as well. You can always create a new object with the empty sign of the corresponding thing. So let's see, empty. So an empty string would be like this. An empty list would be like this. And an empty tuple would be like this. Just so we're complete here. Okay. So we create this empty dictionary, and now we can assign key value pairs to that. So we're going to say the key name is going to be Bob. The key job will have the value, or the value associated with the key name will be Bob. The value associated with the key job will be Dev, and the value associated or assigned to the key age will be 40. So we can create a dictionary that way, and now we have this new dictionary that has these key value pairs. And again, we can pull out the name using this thing. If we want, we can do nested dictionaries. So the values don't have to be just singular, strings or integers. They can also be dictionaries themselves or lists. So here we have a dictionary that has a dictionary as one of its values and a list as another one of its values. So if we wanted to pull out the name of Bob, or the name of this person, we can use the name. We can look up the name using this key name, and then we can look up the last name using this key last. So rec name gives us a dictionary, so then rec name last gives us the value of that key value pair in that nested dictionary. So this is another example where we have the value that's stored to this key job is a list. So if we say wanted the last element of that list, we could use this positional indexing. Because remember that this expression that's highlighted here is itself represents a list. So we can do all the things that we can do with lists, we can do with that expression. This comes up again in Python. The same thing with those methods. So we could do a dot append, or we could, here's an example here. We can say this job, we're going to append this additional job to that person's record. So now he's not just a dev and a manager, he's also a janitor. So he's got some job security in the economy. I just didn't think that was funny. Sorry, that came out of nowhere. But this comes up again and again in Python, where you can whatever that expression represents, you can then do another operation depending on whatever data type that is. So in this case, this expression is a list, so we can do this dot append and append this new element to that list. If our dictionary is, for some reason we want the dictionary to be sorted, typically we try to not worry about the order of the dictionary. That's kind of the advantage. But if we do want to pull out everything in sorted order, we can do that. So first I'm going to pull out the keys and values here, and I might need to. This demo might not work exactly how I planned, because in older versions of Python, the dictionaries were not stored in order, but they've kind of updated it so they are now. But let's just see what happens. So here, what we're going to do is we're going to, when we do a for something in a dictionary, it's going to pull out the keys. So if I want to get all the key value pairs, I can say for key in D, print key, and then D bracket key, and this will give me both the key and the value for that key. Another way to iterate over a dictionary is I can say for key, comma, value in D dot items, and then since this is a method, I'm going to use parentheses here to execute that method, and then put a colon, and then say I'm going to print the key and value. Another way is I can sort. If I really want to make sure those keys are sorted, I can say for key in sorted D, print the key and the value. In fact, I'm gonna do something here. Let me just change the order. Yeah, so now they're out of order. But now when I sort, if I do sorted, you can see that now they're in order. And I'm going to make a new dictionary here. So here we've created a dictionary, we've added something to it, and now we're going to see if that thing we just added is in the dictionary. So if this in notation, we saw this with lists before. It works with dictionaries too, as it looks for the keys. So is this key in the dictionary true? But the key that's not in the dictionary, it's gonna evaluate as false. Another way to do that would be, so this is something you can do in let's say you're looping over all the values or all the keys in a dictionary, or let's say you want to look up a list in a dictionary, but you don't want to get an error if that element doesn't exist. So you can check first if it's there before you do anything. I'll add an example there, but I'm gonna push ahead because I don't want to run out of time. Another really handy way to create dictionaries is using lists. So you can take two lists that have the same length, and you can use a function called zip, and then that will create this zip object, and then from that you can create a dictionary using this function dict, which will create a dictionary. So here we have a list keys and a list values. So the list keys is name, job, zip code, and city, and then the values are John, student, some zip code, and La Jolla. So if we do a zip and then dict, it has to be done in this way, where you have keys and values as two separate inputs to the zip function, and then put that inside a dict function, you'll get a dictionary.